Hello everyone, welcome to this session. In this session, I'm going to discuss about the pressure and pressure measurement. Pressure, we know that one, it is a force per unit area. The force applied over a particular area. Then how the pressure is to be measured? What are the instruments and devices are used for measuring the pressure? I'm going to discuss here. In that, the first type of the devices what we are going to measure for the pressure, this is commonly used for measuring the lower pressure. The manometers, these are called. The manometers are defined as the devices used for measuring the pressure at a point in a fluid by balancing the column of the fluid by the same or another column of liquid. These are classified as follows. The first and that types are simple manometers. In the simple manometers, there are three types. One is piezometer, and second one U-tube manometer, third one is a single column manometer. The piezometer is the simplest type of the manometer which is used for measuring the pressure. It is the piezometer tube which is connected to a pipe. In that the pipe is in that pipe the fluid is flowing at a particular pressure, and due to that pressure the whatever the tube connected in that the fluid will rises, and that rise of the fluid is taken as from the datum center line of the pipe as a height h. If you know this height h, then the pressure we can find out by using the equation, that is a P is equal to rho gh. Rho is the density of the fluid, g is the acceleration due to gravity, h is the height of the fluid which is raised in the piezometer tube. Then second type of the manometer is U-tube manometer. It is named as a U-tube. There the tube is bent like a U. That's why it is called as a U-tube manometer. And here the datum line, the lower level of the heavier fluid which is used in the U-tube, that is taken as the datum. And here the in this U-tube manometer, not directly the fluid which is flowing in the pipe is rising in the U-tube. The another fluid which is a heavier fluid like mercury, that is used in order to measure the somewhat higher pressure. And its lower level is taken as the bottom. Lower level of the heavier fluid is taken as the bottom, and from that the height for which the fluid is uh, falling in the pipe on the particular column which is connected to a pipe and taken, and the another column of the U-tube where the fluid is heavier fluid is raised from the datum line, that height is also taken. And by writing the equation by balancing the both side pressures, and this one here the pressure which is acting at a point A, that is taken as the PA plus half. Okay, what the for the particular height the pressure the this fluid is pushed the heavier fluid downwards for the height H1, and for that we can write that one whatever the pressure equation is there, rho 1 g H1. Rho 1 is the density of this fluid which is flowing at a point A. G is the acceleration due to gravity H1. Okay, and that is equal to the other side, whatever the other column, the what pressure is there, that is rho 2 GH2. The rho 2 is density of this heavier fluid, G, and H2 is the for the height for which it will be raised from the datum line. Okay. Then moving further, the single column manometer. In this single column manometer, the one side of the manometer, the reservoir is connected. The reservoir is having the much higher area than of the tube. This arrangement is made in order to measure the higher pressure. That means because of the higher area, the movement of the fluid, the whatever the due to the pressure, the moving downwards of the fluid, whatever is there, it is very less. Okay, here we can see that one before connecting to the this pipe A, the manometer where the heavier fluid is level XX. When we connect to this pipe, due to that pressure, the level of the heavier fluid will be falls at a distance of dh, the distance of delta h, and that will become a new level of yy. And but here we are going to take the x as the datum line, because here we are going to neglect this if very small decrease in the level whatever is there because of the higher area of the reservoir compared to the tube area. And whatever the level is there, this one h1 we have taken and h2 only from the datum line of xx. And the PA can be given as the PA pressure at point A, rho g h2. The rho g, this h2, rho is the density of the heavier fluid. And here for the h1, whatever the rho A, g h1. Okay, this one h1 from the up to datum line of x-axis it is taken. And here we are going to neglect the whatever the fall of the fluid in the reservoir, and only the rise in the one column we are going to consider, and that's why it is called as a single column manometer. Further moving to the other types of the manometers, those are a differential manometers. The differential manometers are used to measure the difference in the pressure. Okay, if the two pipes are there, pipe A and pipe B, and the difference in the pressure of these two points pipes we want to measure, that differential manometers we can use. For these two pipes at different level, these are the pipe A is at somewhat different level, B is at a different level. For that, if you write the equation again, lower level of the heavier fluid we are going to take as the datum line xx. Above that one, what pressures are there on the uh, side of the left hand side and right hand side, these two we have to take, and we have to balance those one. We have to equate those two, and the difference we can take. The PM minus PB, the separately equation we have written, and the PM minus PB difference we have taken. Okay, then rho, this one rho for this heavier fluid, G into H, okay, other side, plus of rho B into G into Y, minus of that side whatever it is there for the PA side, that we have taken rho A G into X, X plus of this X whatever is there, this X plus of this H, X plus of H. Okay, this will be subtracted because that A side whatever the pressure is there, that will send this side. And by this equation, the difference in the pressure by using this differential manometer we can have. Then the B is A and B are at the same level. These two are at the same level. Then we can write the P and PB difference here, PA minus PB. Okay, then this side rho G into H plus of rho B into G into X minus of this side rho A G, this H plus of X. This distance can be given as this whatever from the datum line XX, the height whatever is there, X plus H, X plus H. By using this one, the difference in the pressure we can find out. Similarly, the other type of the manometer, that is a inverted differential manometer. The inverted differential manometer PA minus PB can be written as rho 1 GH1. The rho 1 GH1 is this one, minus of rho 2 GH2 minus SG into AC. S is that is density of this particular fluid. And again the inverted, here we are going to balance the same way. Okay, the only the equation here the plus we are going to take, and here the minus we have to take for that one. That is the difference between the inverted and vertical differential manometers. Next, moving further, the other types of the pressure measuring devices are the mechanical gauges. How these mechanical gauges, the pressure is measured? The pressure is measured by balancing the fluid column by spring, there is elastic element, or a dead weight in these devices. Okay, the fluid column, whatever the elastic element is used, or a dead weight is used for measuring the pressure. Here, generally these gauges are used for measuring the high pressure. For the high pressure, we are going to use lower pressure, we can use the manometer. For the high pressure, we are going to use the mechanical gauges. And where high precision is not required, high precision is not required for that, some commonly used mechanical gauges are: first one is a Bourdon tube pressure gauge. The first one, this is the Bourdon tube pressure gauge. In this Bourdon tube pressure gauge means whenever the fluid at a higher pressure enters here, the whatever the curved tube is there, that will bend. That will bend. And due to the bending, the whatever the needle is there, that will move to read the pressure. And second one is a diaphragm pressure gauge. This is the diaphragm. Okay, here the diaphragm, due to the pressure, diaphragm will move up and down. If this is moving up and down, then the link connected to that dial which will be moving, and thereby the whatever the dial gauge is there, which will indicates the pressure. Next one is the bellow pressure gauge. The bellows are used here. These bellows are operated depending upon the pressure applied over there, and due to that pressure, the dial gauge will be moving to read the pressure. Next one is the deadweight pressure gauge. Deadweight pressure gauge usually used for the calibration of the pressure gauges. Okay, the calibration of pressure gauge is meant for the particular weight. Okay, if you apply that force, we can have the force per area, what the pressure is there, that we can calculate from that dead weight. And from that, the pressure, how much it is acting here, we can read. And from that, the pressure gauge, what will be connected, that also reads the pressure. Then the calculated value of the pressure and this pressure read by the deadweight pressure gauge should be same. Then the pressure gauge, whatever is there, that will be calibrated. That will be reading the same that values. And like this, the different types of the pressure gauges are used. And in detail, the how the actually uh, this balancing and how the actual movement, all these things I'll discuss in further sessions. Thank you. If you like, share, subscribe, and comment.